Hi, in this video we are going to see how we can perform anomaly detection using isolation forest. Now I'll talk about what is isolation forest and what the algorithm does, but let's first understand the data set and the packages we are going to import. So for this video, I'm going to use scikit-learn ensemble package, which has the isolation forest algorithm. I'm going to use matplotlib and plotly express for visualization and pandas for loading and kind of processing the data. So that's what I am importing over here. And then I'm going to take the data set from this particular GitHub repo. This particular GitHub repo has a lot of time series data set. And this is a time series data set. And what we are going to do is detect anomalies in time series. So this repo, I'm going to pick the NYC underscore taxi data set. You can go to this data set. You can find plenty of interesting time series data set to play around. So I have imported that, and let me quickly print the data frame that I have imported. So if you see over here, this basically has all the taxi rides that happens in New York City from 2015 to 2014 to 2015, right? It's around 6 or 7 months of data, and the data set is for every 30 minutes. So every 30 minutes it tell like how many New York taxi ride shares has happened in the city. So at say like 0107, that is July 1st, there are around 10,844 New York taxi rides that are active at midnight 12 o'clock. Similarly, like every 30 minutes you have the data. Now what I'm going to do is I'm going to like quickly first take this data set and do some kind of cleaning and data type change. So I'm taking this particular column, timestamp column, I'm converting it into timestamp. Let us first see like what is the actual data type. So let me print like df.info, and you can see this particular data set timestamp is an object, which is kind of a string column. For us to do some time series analysis, we need to have the date time column in the timestamp data type. So you can index it, you can go and query and search it, you can do a partial search if it's an timestamp column. That's the idea over here. So what I'm doing is I'm taking the timestamp column, I'm doing a to date time, so it will convert the object into an timestamp data type. And let me print the output now. Now you can see basically the object data type is a date time data type now, right? Let me quickly print some of the output also. It's still the same. You have the timestamp column and the value column. Now what I can actually do is like I have every 30 minutes of data. I have too many samples. I can aggregate it such that my output pattern is not changing. So in this case, rather than having every 30 minutes of data, I'm going to aggregate into every hour of data. So how I can do that is I can basically have pandas resample method. So in this case, I'm telling resample the data set to hourly basis and take the mean value. So it's going to take the first two value. It's going to say like 10,844 plus 8127 by 2 and then aggregate it. Similarly, it's going to do for each observation over here. And then I'm doing a set index of timestamp because a resample needs to be on an index column, and then finally I'm doing the reset index so that it comes back to the normal value. Now if you see the output, rather than having a 30 minutes interval, we are having like an hourly interval over here. Right now I'm going to add few columns to the data frame. The very first column I'm going to add is I am taking this particular data frame, I'm creating a hour column, I'm telling from the timestamp column just take the hour part of it. So the idea is I want to see every hour, which is the maximum hour in a day, the right shares are higher, and how does the right share behave throughout the day or throughout the entire data set period that we have. So I'm taking this hour column and assigning it to df.hour. Then I also want to see how does the New York taxi rides vary across the weekdays. So typically in New York City, a lot of people come for a job. So during the weekdays, the rides will be higher, and weekends it will be slightly lower. Not that lower as well, because New York also is an good tourist destination. There will be a lot of weekend activity going on. So I am also creating an weekday column. In the weekday, what I'm doing is I'm converting the weekday column into categorical value. I am taking the timestamp column and I am just telling that pick the weekday. It will the percentage a, you can go and check the documentation for this string time function. But in this case, what percentage will give me whether it's an Monday, Tuesday, or Thursday, or Wednesday, or whatever the weekday is. And I'm saying these are my categories: Monday, Tuesday, Wednesday. You don't have to do that. You can just take this inner value and then assign it. But what it will do is it will not understand the order of data, right? So only for that case I'm doing is categorical, and I am telling Monday, Tuesday, and I'm telling that ordered equal to true. So when I'm plotting it, it will plot in the same order that I have given over here: Monday, Tuesday, Wednesday, Thursday, Friday. And that's the reason I'm doing it out pd dot categorical value. Now this two is done. Let me print the info. Now I have two additional columns that is added. Apart from timestamp and value, I have hour, which is an integer, and weekday, that is a categorical. So let's quickly print the data set as well. This is how my data set now looks like. I have added two new columns. Now what I'm going to do is I'm going to plot the data on per weekday, right? Like how does my data, how does my write behave on Monday, Tuesday, Wednesday, Thursday, Friday? So is there a pattern to it? That's what I'm doing over here. I'm taking from the data frame value column and the weekday column. I am grouped by weekday, and I'm calculating the mean of the value for every weekday, and I'm plotting it. So let me run the plot so that you can see the output. Now the below is the weekday. Now see the x-axis label is not coming. The latest version of Panda has some bug. So but it is Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. The same order it is, and you can see the value on the y-axis. And basically, if you see the value, usually during the Monday, Tuesday, Wednesday, the weekday, the right share rises till Saturday, and it comes down during Sunday, right? That's what basically the pattern is. During the weekday, the right shares are pretty higher. Even the Saturday, it is kind of higher, and Sunday it kind of falls down. As I said, New York is also a tourist place. There will be a lot of activity during Saturday, but Sunday typically people come back and rest so that they can start the weekday other, right? Let's see at the hour level how the plot is. So during the day there are 24 hours. So how the plot is? If you see this 24 hours plot, you can see basically in the morning time between 0 to 5, right? The right shares are decreasing, but after 5 o'clock the right share starts increasing, and during around 3 o'clock it slightly falls, but it increases throughout the day till almost like if you take 11 o'clock or something like that. So during the office hours, the right shares are continuous, it's like increasing, and during the night hours and early morning hours, you can see the right shares are falling, right? So that's how the pattern looks like. Right now, what I'm going to do is I'm going to like kind of use Plotly Express to plot the entire data. So I have data from 2015 July till 2014 July till 2015 January end. So I'm quickly using Plotly Express here. I'm drawing a line plot. I am giving my data frame. I am telling x-axis is my timestamp, y-axis is my value, and I'm giving a slider. So what Plotly Express allows you to do it, it will give you a slider at the bottom where you can drag and drop and zoom into a particular point, right? So this is how my data set looks like. Now you can see there are some peaks over here, and there are some bottom in this place. So in one good thing about Plotly Express is you can kind of zoom into a particular point. You can see this particular this November 2nd 2014, there was a very big peak compared to the normal point, that is around 37,000 right shares were there. And similarly, like what I can do, I can do a slide. This is a slider that it was there, so I can move the slider and see like if there's any other point. If you see over here typically the value is pretty low over here. There are only 800 right shares, which is not quite common in New York City, right? It's kind of a sleepless city, and people are all the time riding. But these are the anomalous point in my data frame. The 2nd November, which you saw, there was a peak on top with 30,000, right? That was because there was an NYC marathon in that time. So New York Marathon is a pretty famous event. People travel all around the world to run in the marathon. During Thanksgiving, there was an anomalous point. During Christmas, there was an anomalous point. So what does this anomalous point mean, right? It's a time series data. Now, typically you expect on Thursday, the right share to be higher, but due to Christmas and Thanksgiving, it can fall during maybe assume like Thursday or Friday, right? Now, what is going to happen on that day? The right share will be completely less, because people, it's a holiday and people tend to stay at home with the family. And similarly, New Year, which is like during the midnight. If you see the pattern during the midnight to the morning, the right shares are typically lower. But in this case, if you see on 0101, let me go to that point. Maybe it's around this place. Let me see. Okay, 5th Jan. So here is Jan first, right? Now you can actually see during the midnight its peak. But typically, if you see the trend that we saw at our level during the midnight's bottom, the reason is on New York Times Square is an most happening place in the world. People come to Times Square to do the countdown and everything, and the number of taxi rides are pretty higher, because people, after doing the countdown, they return to home, right? So that's why you are seeing that these are kind of anomalous points. Now, what we are going to see is whether our model is able to detect this anomalous point. We are going to build a model and see if it's able to going to detect it. And again, there's a snow blizzard. So during snow blizzard, typically the taxi is pretty low, because people stay at home. It's very difficult to drive during the snow time. So 26 Jan and 27 Jan was snow blizzard, and that time the taxi rates were pretty low, and that was the lower peak point that you saw over here, right? If you see this particular point, if you see it's 22nd, 26 Jan, and this was snow blizzard, and only like around 324 taxis were running, which is pretty low, right? So let's see. What I'm going to do is I'm going to use isolation forest. I'm going to use with some hyperparameter and without some hyperparameter, and tell both way how you can use isolation forest. So before going there, isolation forest is an unsupervised learning algorithm for anomaly detection that works on the principle of isolating anomalies, right? It's in the name itself. Now, what isolation forest does, it builds an ensemble of isolation trees for the data set. An anomaly or point that have shorter average length on the isolation trees. I will talk about more it. I'm just like giving some idea of isolation forest. Now, to go further, what isolation forest does, it isolates the observation by randomly selecting some features. Now, in this case, I have only one feature, but it can randomly isolate. If I have 20 features, it will randomly pick some features and start this isolating these anomalies by splitting the value between the minimum and maximum range. And as it split, it's going to see the anomalous point that stands apart, right? That's what it's going to do. So it's kind of an ensemble tree based algorithm. It's similar to your GBM, it's similar to your XGBoost, but it works on a different principle, and it's unsupervised, right? So here I am building my isolation forest. I'm setting a hyperparameter called contamination level. Now, this contamination level, we are telling that amount of contamination in the data set, that is the proportion of outliers in the data set that we want to identify, right? So now, how did I come at the contamination level? This is basically, I understand the data set, I have tried multiple things, and I came at point not 4. You can apply your domain knowledge. There are multiple factors, but I'm going to also show like how you can run without the contamination level, because in a lot of some data set when you take, you may not know the contamination level until you try out multiple combination. In this case, I'm setting it to point not 4. It's a value between 0 to zero point 0.5, right? And I am just passing my value column into the data frame. I'm doing a model.fit.value. So let this run. Now, by default, it has kind of taken the number of estimators as 100. That is the default. If you want, you can change the number of estimator. Number of estimator is nothing but number of trees that you want to build, right? And the max features is 1.0. I'm taking all the feature, but you can, if you have a lot of features, you can tune that as well. Now, what I'm going to do, since I've set the contamination level, when I call my model.predict, right, it will give two values. It will give in 1 and -1, right? When it's -1, that means that point is anomaly. When it's not -1, that means that point is not anomaly. So what I'm doing is I'm calling the model.predict of this value, and I'm calling a lambda function. I'm telling if x equal to -1, right? That is, then it's yes, then it's anomaly, otherwise no. Now, this is because the contamination level is set. The predict will give me whether that particular value is contaminated or not. That's what it's going to do, right? So let me run this, and assigning to the same data frame as a column called outliers. So let me run this. Now, what I'm doing is I'm going to the same data frame, and I'm telling my outliers equal to yes. So let's see what are all the outliers it detected. Now if you go back on the top, you can actually see it detected 22nd November, right? That was the day when New York Marathon has happened. It detected that as an outlier, yes. It detected the New Year day, one of the data point as outlier, yes. Right. And let's see, like it also detected the blizzards, right? 26, 27, there was an snow blizzard and the rides were pretty low. It detected that as an outlier, but it did not detect the Christmas Day, that is 25/12, and 27/11, which is kind of the Thanksgiving Day, did not detect, right? Now, why it did not detect, right? When we talk about anomalies, there are two type of anomalies. One are observation that are completely outside of your typical data set range, right? These are if you take an standard deviation, it is like more than two standard deviation, or more than any standard deviation that you deem it as outliers for your business requirement, right? But in real world there can be outliers which are not really a data outlier, are more like a contextual outlier, right? That outlier is only an outlier in the context of the business. So in the case of Thanksgiving and Christmas, maybe the data point in that case was not really like a value 30,000 or lower value 100 that is standing out. It is within the normal range of it, and that's why it did not detect. And I will tell you how to solve that problem. So these are outliers. Let me print the data frame now. You can see both S and no value. No are basically non-outliers, S are outliers. Let me again plot this in the Plotly Express, and this time what I'm doing is I am having the same thing. I am color using the outliers column that I created as color, so that I can see which points are outlier. And when I am going to the data, I'm also seeing like weekday as an tooltip over there. So let me run this, and let's see like what is the outliers that are protected. So if you see this, it has taken all the points that lie in the bottom or top in the normal range and detected outliers. But as I said, some points will be within this blue color, which may be outlier. Like say on typically on Sunday, you don't get a lot of rides, but on that particular Sunday, maybe there was a game event and you saw a lot of rights. That will not come in this global outlier. It may come in the contextual outlier, right? And that's the reason the Thanksgiving and your Christmas was not detected, right? So this is one way. The second way, I don't know my contamination level, right? Now what I can do in this case is I can run my isolation forest without any parameters. You can add other parameters like a number of estimators, max features, but in this case I'm going to run without any parameters, so I don't know my contamination level. I'm running for everything. In this case the contamination is going to be auto, so the model is going to detect the contamination level, but it may not do a great job, right? It's you can plot it again and see, but it may not do a great job. So in this case, rather than doing the model.predict function, what I want to do is I need to get a score in this case for each and every point, and that's what I'm going to do, right? So I am calling the model.decision functions and passing the data frame, and it will give me a score. So let me run this from the train model. Let me call the decision function get a score, and let me now print the score. Now the score will be a bunch of points, bunch of negative and positive value that you will get. What I'm going to take is I'm going to take this score and create a histogram out of it, right? Now I'm telling my bins as 50. I'm going to take the score, I'm going to create a histogram. Now this histogram, you can see it like this. So there are a lot of points that are on the higher end, but there are some points over here. Now these are your probable outliers. The value at the lowest range of the histogram are your probable outliers. Now you can set a threshold over here. I can set a threshold at say somewhere like 0.24, or I can set a threshold at 0.15. This you can run in multiple iteration and see which is the best threshold, right? So now anything that is less than 0.20 can be an outlier, a minus 0.20. Anything that is less than minus 0.15 can be an outlier, right? So this is a threshold you can set when you don't know the contamination level. So what I'm going to do is I'm going to take this value, I'm going to assign the score data to an another variable called scores in the data frame. And now if I print the data frame for each of the observation that we saw, I'm going to also have some set of scores. So now I have outliers which I got from the previous model where I had the contamination level. Now this score is without any contamination level. Now in order to for me to find which are the outliers, what I'm going to do is I'm going to do a df dot query scores less than minus 0.20. And how did we get minus 0.20? From the histogram. Now I am setting a threshold. Okay, anything less than minus 0.20 is an outlier. Now you can even go and have a even more strict range, that is 0.24 or 0.23 or whatever range, right? So let's see like how the output looks like in this case. Let me run this. I'm selecting only less than 0.20, and now you can see basically the same thing, right? It detected the blizzards over here where the rides were pretty less, and it kind of detected the 22nd 11 where the New York Marathon was there. It detected the 1st of Jan where you had the New Year event. It still did not detect it still did not detect the basically your Thanksgiving and your Christmas, right? It detected the year end additional point that again in New York New Year event, but not detect that. And why it did not detect again? See, this is basically not a time series. I'm modeling a time series data with a non-time series model. If you have seen my profit model that I created, it was better in detecting outliers. The reason this was not able to detect is because we are not fed any intelligence to the model, like features that can help the model separate the outliers better. So that's where feature engineering comes into play. So what I'm going to do is I'm going to take the same data set. I'm going to create additional features that I'll feed as intelligence to my model and see how the model is able to isolate the other outliers as well. Because currently the model is only isolating the global outliers. It is not isolating your contextual outliers or local outliers. And that's what we are going to do in our next video. I'm going to take this, I'm going to create additional features in the form of like weekday events or hourly events, and then see how my model performs better. Thank you very much.